Okay, the third gas law that you need to know out of these 5, this one's called Lussac. That's the name of the man that invented it. Here's Gay-Lussac's law. With Gay-Lussac's law, we're going to manipulate pressure and temperature. And we're going to keep volume constant. Okay, so P1, T1, those are our starting conditions. And then we're going to change one at P2 or T2 and then do some math, right? So pressure and temperature is the relationship of Gay-Lussac's law. This is also a direct relationship, Gay-Lussac's law. So one goes up, the other goes up. Direct relationship. One goes up, the other goes up. So if we look here, the example that we're going to use of Gay-Lussac's law is NASCAR tires. The tires on a NASCAR race car. Okay, so I'm going to show you some math here. So we pull up at the start of the race. Here's the start of the race. Pressure, notice I use the English unit, PSI, 30 PSI, that's a little low for tires. Temperature, 80 degrees Fahrenheit, only I use the F word. I've converted that into 300 Kelvin because we have to use Kelvin when we do math for our gas law. So, somebody says, Dale, pressure's too low in the tires. And this driver, he just forget it, he's gonna start the race anyway. So 3 laps later, what happens, right? This car's going 200 miles an hour, skidding around the turns, there's a lot of heat. So now the temperature has gone up from 80 Fahrenheit to 120 Fahrenheit, which is 322 degrees Kelvin. So if one goes up, the other goes up. So notice when I do the math here, I have 30 PSI and 300 Kelvin. That's what we started at. P1 and T1. Then we went up with the temperature to 322 Kelvin. He went a few laps, his tires got really hot. So what happened? One goes up, the other goes up. 3 divided by 300 is 0.1. So this math has to also be 0.1. And so if you notice here that after 3 laps, the tire pressure went up to 32 Fahrenheit, right on target. Go Dale.